Hello, in this video we're gonna look at problem 55b of my calculus book. It asks smallest slope. What is the smallest slope on the curve on the curve? At what point on the curve does the curve have this slope? So this is a continuation of the previous video that I made on normal lines to a curve. So we had this curve at y equals x cubed minus 4x plus 1. And we graphed this, and we graphed all three things together: the curve, the normal line, and the tangent line. So let's go ahead and run it again, but only with the curve only, not the tangent or the normal. So we're looking at this curve, and we're looking at what point does this curve have a smallest slope. All right, so let's put in our coordinate system again. So we have xy like this. So let's say I have a curve like this, whatever, something like that. This is something like a cubic, or looks like a quadratic function, not a parabola. So smallest slope would probably happen here, and it would look something like this. Let's put that in. So this would be the smallest slope. It is negative, and it's very steep. It's almost like vertical, but it is not. Vertical line would be undefined, obviously, but the smallest slope is a very small number that we're interested in. So that's what they're asking in this problem. So let's go back to our problem, and we don't know. Maybe the smallest slope happens here, along a point over here, and well, that would make it a positive slope though. So smallest slope of this curve would need to be a negative number, maybe, or a positive number. We'll see what it is. So let's go ahead and use MATLAB and see what that is. So let's go ahead and comment these. I don't need these now for now. So to solve this problem though, we're gonna know d2y equals differential. So it would be diff y, and we're gonna take the second derivative of y. So that's d2y, and so x2 now is solve d2y. So this finds our x-intercepts of the function of the new derivative, the second derivative of the function, and smallest slope equals subs dy comma x2. And now I'm going to evaluate the function at x2. So y2 equals subs y comma x2. So this is our new coordinate point. So we have x2, y2 now. All right, so we're gonna now put in a fprintf command. So we're gonna say, let's see, f equals %s has the smallest slope of %s at the point %s. Let's see, point like this. So we're gonna say %s comma %s, and we're gonna come out and do \n twice, and comma y comma smallest slope. Okay, and then we have x2 y2 comma y2. All right, let's see. Let's go ahead and run this and see what we get. So it says f equals, the function has the smallest slope of -4 at the point 0, 1. So the smallest slope is negative value, and it occurs at the point 0, 1. So let's go ahead and graph this. So we're going to graph what this smallest slope looks like. So this is now the equation of the smallest line. So we found the smallest slope. Now the smallest line then would be the slope-intercept form of a line. So it would be the smallest slope, which is similar to m, times x minus x2 plus y2. So this is the point slope form. We moved y2 over to the right side. So now let's go ahead and graph everything. All right, so let's go ahead and run it and see what our graph looks like. So this is our graph. So we have the function that was given to us originally, and the smallest slope occurs at the point 0, 1, and it's a negative slope. And I've sketched both. The curve and the line is in red, and we have a legend to distinguish between which is which. So that's how we solve this problem. Thanks for watching.